Welcome and very good morning, everyone. So we're going to start our lecture today for the topics of the machine code, or we also call it machine language. So this is the one that the machine can understand, where when we write the program, we are already writing in assembly language, and once we execute it, so the system will, the assembler will change the machine code to the the assembly language to machine code, where your CPU can execute it. So in terms of the definitions of machine code is a computer program written in machine language instructions that can be executed directly by the computer central processing unit. So your CPU is only can talk with the machine code, not by using your assembly language, where assembly language is for us to write down the code. Okay, so for example, we just want to show you in the assembly using your simulator. Okay, alright, so let's try a very simple command here. For example, move dot byte d1 to d2. So this is a command for you to move a byte size from d1 to d2 in assembly language. So the CPU cannot use this language to execute the process. So what you have to do, you have to execute or assemble it, compile it, sorry. So you can see that here, this page. So this is your assembly language. And you can see that you are starting your origin at 1000, means that you are going to put your program starting at 1000 location at the memory. So this is your memory starting from 000 up to FFFF, which is a very long one down here, around 6 meg like last time, right? So you can see that this is basically the machine code, or the machine language in hexa numbers is 1401. Okay, so this instructions is basically with this machine language 1401. So let's try change to a number, maybe this one to d3, right? Move dot byte d1 to d3. So it's changed again to 1601. Okay, so it's very unique. So let's try move dot words d1 to d3. It's changed to 3601. So we can say that every time you write the code or syntax, it will have its own unique language, so it can execute it. So it means that once you execute your CPU, it will take this machine code, which is basically these instructions, and the machine code will be executed. Okay, so today's lecture is actually how we are going to come up with the instruction codes, which is the machine codes, from the assembly language. So we are going to from this assembly, we are going to change it to this machine code. So there are tools that you need to know, and there are the tools that you need to understand how to use it. So the materials is already uploaded in the Udemy or the Microsoft Teams. So if you go to your Microsoft Teams, at the Teams over here, you go to the Teams, your MicroProcessor Teams. You can go to your files and you can download this one. Alright, so you can download here. Okay, so this is the programmer's reference manual. Okay, so it's actually a very thick book, very big, very thick. So you may not need to read all of them, but we are going to concentrate at section 4. This is the section 4 here, which is the integer instructions, which is related to the instruction formats. Okay, so you just can just go to section 4. Let's go to section 4. Okay, this is section 4. Integer instruction at page 4-1, section 4, page 1. So you can see that this is the instructions that we may have learned or not yet, because sometimes we are not going to touch everything. So ABCD is an instruction that we never touched before. So we have this one add, right? So this is, remember that this is all we have in the arithmetic at address, and the rest is actually very long, up to page quite long. So you have to find out the command that you are going to do with the format for the instructions inside formats. Okay, for example, here now we are going to go back to the move instruction. So that at the instruction manual you have to find out the move. So this is an alphabetical order. So after this we have to go to M. So if I'm not mistaken, the page will be 116, section 4. Yeah, that's all. Okay, so move starts from 116, 117, and 118. Okay, so this is the one. Right, so what you need to know is you need to read and understand how it is used for the instruction format. For the instruction format here, for example, here is the one, right? So okay. Now look at the command again. Right. So I try to okay. You can see that here this is actually the move instruction. So the operation will be the source to destination. So this is going to be your source, D1 to D3 is the destination. Okay, so D1 to D3 will be destinations. So based on this one, this is correct. Source will be source to destination. Assembly syntax is move effective address to any effective address. So you can see that this is the effective address of the first one, and also this is also the first one, the second one. Sorry. So this is like this. The pattern, okay, the pattern move move EA to another effective address. Okay, so the size will be this one, and this is the flag. Remember that there are 5 flags that we have learned so far, right? So this is the instruction format. This is the one that you need to learn how to fill up those things. Okay, the instruction format is a 16-bit. You can see that here 0 to 15 is a 16-bit size. So you have to know that how to insert all these things. For example, here for the move instructions, you have the 2 on the left numbers is actually a permanent numbers, which is 0, 0, and the rest you have to change it accordingly to the instructions that you write down. Okay, now here for example, the instruction fields for size, for these 2 size, you are going to run it based on the operation of the size. Okay, for example, if you run byte, you have to put 0, 1. If you run word, you have to put 1, 1, and long word is 1, 0. Okay, so next one for the destination and register mode. Destination is here, D3, and the source is D1. So destination for the register and mode will be referring to the D3, and the source, mode, and register will be referring to D1. So how to take this figure, the number, you have to follow the tables on the next one. Here and here. So read this one, right? The first one is for the destination effective address. For the destination effective address field, which is this one. This is destination effective address. This one will specify the destination location. So this is a table you need to refer to. Okay, so here you have the addressing modes. This is your command. Then you have the mode, and you have the register. So basically you are referring to this table. Okay, now we try to put down this one, destination and register mode. So there are 3 bits for the register and modes. So for the first one, you are going to look at D3. This is the pattern D3, right? D3 means the pattern will be coming from DN. DN is a data register, so the pattern is DN to DN. Alright, so now the destination is DN. We are going to take these values. So mode will be 000 here, and the register will be the register number. What does it mean of register number? So what's the register number that we have over here? For example, D3, this is the register number. This is the register number 3. Okay, so you have to convert it to binary. 3 means 0, 1, 1. Okay, there are 3 bits size, right? So the mode is 000 and the register number is 011. So same thing like the source over here. Source, you are looking over here at D1. Okay, so D1 source, mode and register. So you have to go to the mode first, and you have to remember that this is for the destination, so you have to go to the source table, source effective address field. So you are looking at DN also. DN means DN, this one. So the mode will be 000, and the register number is the register number of the data register. For example, here 1, here 1, so it will be like this, 001. So that's the figure number. So all is this information that you already have, so you have to insert it. So how to insert that? So let's try to put the instruction format value over here. Let's try. Have to push everything first. Okay, again, so you have this one 00, correct, right? Size based on the instruction is move.w. .w word operation is 11. So what you have to do is you write down this one 1. This is also 1. Let me try to put the size much bigger. This is 1. This is also 1. Okay, so the mode, sorry, this is 1, and also this is also 1. So for the destination here just now, the register is register number 3, so it's 0, 0, 1, and the mode is based on the table is 0, 0, 0. So this is 0, 0, 0, and for the source you have to put the mode first. Source mode is 0, 0, 0 also, 0, 0, 0, and the register is the register number 1 here, right? So register number 1 means that 0, 0, 1. So if you write down everything first, again, the number will be like this, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, and 0, 0, 1. So this is the full numbers like this. So then you complete the binary numbers. The instruction format in binary is already completed, so let's convert it to hexa. So like previously, you divide it to section by sections, right? So this one is 1 plus 2 is 3. 1 plus 2 is 3. This is 2. This is 0. This is 1. So the answer is $3201. So is it correct? So let's look at the command over here. I have to remove this one first. Alright, so this is a command. Hopefully it's 3201. Oh, sorry, 36. Is it 6? Oh, register, sorry, this is not 001, right? This is 011, sorry. This is a 0, 0011, 0, this is 1, basically this is 1. So this is basically here. So in terms of, instead of 2 is, this is 6 basically, and this is 6. 3601, and the answer is correct, 3601. Right, so sorry about this one. This is basically if you look back, this is not 1 because this is register number, this is register number 3, so it should be 011 here. Okay, so let's try another one. Okay, let's try another example. This one, D1. Let's move A3 bracket to D6. Okay. The pattern now is like this: move.w effective address to any effective address, right? So again, you have to refer back the move instruction here. Let's try to put one by one. Okay. The first one is 00. The size is .w, so w word operation is 11. Okay, so you have to put 11 there. 11. Okay. So destination register, this is D6 destination. So destination register, let's look at this one. So you again have to refer to DN because this is a DN. This is a AN, and this is a DN, right? So refer to DN for destination. Mode will be 000. Mode will be 000. Mode will be 00, and the register will be the register number. For example, that one is 6. Register number 6. So you have to convert 6 from these 10 numbers to binary. So 6 will be 110, right? 4 plus 2 is 6. So now you are going to put the register 110. 110. Mode is 0, 0, 0, right? So your source now is actually this pattern A3. Your source, you have to refer to the source table, source effective address here. So you are referring to AN. Your mode will be 001, and again the register is based on the register's numbers for the address here. So this is A3, the number will be 3. Okay, convert it to hexa, binary. 3 means 0 1 1. Okay, and the mode is 0 0 1. So insert back that one. Mode will be 0 0 1, and the register is number 3 0 1 1 1. So the final instruction format value will be 0 0 1 1 1 1 0 0 0 0 0 0 1 0 1 1. So calculate this one: 1 2 4 6 8 10 12 14 16. So it's 16-bit size. So you're going to convert it to hexa numbers. Let's try over here. The hexa numbers will be, so we divide it into sections: 1 2 3 4 1 2 3 4. Alright, so this one will be 2 plus 1 is 3. This is 8 plus 4 is 12. 12 in hexa is C. This is 0. This is 8 plus 2 plus 1 is 11. Correct, right? 11 means P. So the answer is $3C OB. 0. You're correct. So let's run this one. Remove this one and remove this one. Remove this one. Run this one. So TC13. Do I put it wrongly? TC13. Right. TCAB. Am I looking at the right one just now? So the source 001. Did I put it side by side? Just hold on, 001. D6 6 means 3 001. No, it's correct, 001, and the number is 3. I have problems on the last numbers, just need to figure out destination D6 D6. Why is 3C13? Is this correct? Should be 0. Mode for the source is what? Mode for the source is 00. Sorry, the mode for the source is not 001. Sorry, I'm sorry. This is a bracket A3. Bracket A3, we have to refer to this one. 010. Sorry, I'm sorry. 010. So so here 010, and the register is A3 is going to be 011. Alright, I'm sorry, this is bracket. Bracket, you have to refer to the bracket bracket tables here. This is the one. Right, 010, not AN. So this is bracket. I'm sorry for that one. Okay. So you have the value here. Let's try again. We have 0 0 1 1 1 1 0 0 0 0 0 1 0 0 1 1. So again 1 2 3 4 5 6 7 8 9 10. So it should be 16-bit. I'm going to convert it to hexa numbers. Okay, this is going to be 3, right? This is 12, this is C, this is 1, and this is 3. So the answer is going to be $3C 13. So let's check whether it's correct or not. Yeah, it's 3C13. Sorry for now, just now I refer to A3, not bracket A3. So we tried another one just now. So go back to this one, Okay, now look at this one. Again, another example, move.long. So we try to directly go to the $sign. Example 1200 to D3. So this is directly from the address of the memory. Move something from there to D3, right? So let's try to fill up the instruction form. So back to the instruction formats. Okay, the first two numbers is a permanent numbers. Size is .long. .long is long operation, so this is 10, 10. Okay, the destination here is D3, so this is the effective address, destination 3. So D3 means data register, register means 3, 3 means 0 1 1, and the mode for the destination, you're going to take 0 0 0 here accordingly from the tables. So this is 0 0 0. So now for the source, you have this direct access to the address $1200. So you have to go for the source table. So based on this one, which one that you need to refer? So you cannot refer data. This is not the pattern. You cannot refer to address here, address here. You cannot. This is displacement. You also cannot. So left only these three. Okay, this one is also displacement. You cannot use it. Displacement cannot use it. So this is a hash. Hash means a direct data. Also cannot be used. So left only 2. So which one is which one for this one? Okay. So if you can remember that before this we learned about the absolute short and absolute long. So what is this absolute short? Absolute short means that you only have 4 digits of hexa numbers. For example here, right, let me check. $4000. Let's make it bigger. Okay. This is only 4 digits of hexa, 1 2 3 4. So we are going to use this one as a absolute short. For the case of more than 4 digits, for example, $sign 1,4000. Once you exceed 4 digits, they call it absolute long. So remember that lower than 4, normally we have to use 4 digits only, right? You cannot use 3, right? 1000 is also 4 digits, right? Like that. So if you want to use 3 digits, you cannot use that in the system. So 4 digits is considered absolute short, and this one is considered absolute long. More than 4 digits, more than 4 digits. For example, here you have another 8 digit here, so it's more than this one. So this is actually your biggest number here. So this is 4 digits, this is 4 digits. So this is absolute short and absolute long. So on the table side, so which one is referring to the absolute short and absolute long? So you can see that this is W. W means words, and this is long. So W is for absolute short, and .L is for the absolute long. Okay, back to the you need to put out this one, the mode and the register. Okay, the command just now is 1200. Now you have to refer to the tables here. For the source, the mode will be 111 and the register is 0000, because you are choosing the absolute short here. This is absolute long, so go for the absolute short here. The mode is 111 and the register is 0000. So the mode is 111 111, and the register is directly from there is 000. So the full instruction address will be 0 0 1 0 0 1 1 0 0 0 1 1 1 and 0 0 0. So is it 16? 2 4 6 8 10. Right, so this is 16 numbers, 16 digits. Okay, so again divide it to the sections here. 1 2 3 4 1 2 3 4. Okay, now convert it to hexa. This is 2, this is 6, this is 3, and this is 8. So the answer is $2638. Is it correct? Hopefully it's correct. Yeah, it's 2638. So this example is correct. Okay, let's try again another example. Instead of all data register, we are going to have another pattern over here for the absolute long. $50,000. Okay, move dot byte. Okay, let's try to insert all the numbers. Okay, so back to the instruction codes. Okay, the first two is correct. Then the size is a byte. Byte means you have to use byte operation. This is 01. Destination register and mode. Destination register and mode. So you are looking at here. So how many digits? This is not a bracket. This is directly to the address memory location. So how many digits? This is 1 2 3 4 5 digits. Then you have to consider a absolute long. Okay, it's more than 4. So for the destination, you have to look at the tables over here. So now dot long, you have the mode 111 and 001 for the register. Okay, destination register is for this one, right? Okay, 001 001, and the mode will be 111. Same goes to the source. Source, you have to refer to the source table. So this is back to the 4 digits directly, $sign. So you are choosing the absolute short over here. The mode will be 111 and the register will be 000. So the final answer will be 00001 0 0 1 1 1 1 1 1 1 and 0 0 0 2 4 6 8 10. So total is 16. So take this number and divide the sections over here. Okay, this is 1, this is 3, this is F, and this is 8. So hopefully the answer is correct, 1 3 F8 for the sign. Let's compile it. Yeah, it's 1 3 F8. So the first 3 example for the move and the important patterns is already been taught. Okay, so let's move on. Now we are going to learn about other than move. So we are going to learn about add. Dot by let's try a number. Hash number 12 to data register data value number 4. Right, so is there any problem with the execution? So no problem. So for the add.byte, right, so we have to go to the add, not to the move again. So we have to refer to the add instructions. So add instruction, go back to the manual reference, and you can see that is from the starting page. Sorry. This one, untitled instructions. So the first one is ABCD. So this is add. Add starts at 4-4 to 4-6. So we have to understand how it works. Okay. Now look at the pattern here. It's a source plus destinations and save to destination. So this is your source, this is also your destination. So in the assembly syntax, there must be add effective address. One of them must be dn, or the second one is add dn to effective address. The first one must be dn2, means one of them must be data register at least. So here you can see the pattern here like this. At this is your first effective address, and the second one is data register. This is the one. You cannot choose the second one here because the first one is data register, which is not correct. So you are referring to the first one here, the first example here. Alright. Now look at the instruction format here, different from the rest. Just now we don't have this one. Just now we only have 2 permanent numbers. Now you have 4 permanent numbers. The rest you have to insert it. You have the registers, you have the op mode, you have the effective address. The effective address is this one. Okay. Okay, let's try to put up that one. This example. Put first. Okay. Now look at the next page for these 2 pages, right? So you look at here, the instruction field for the register field. This is register field. Okay, specifies any of the 8 data register. Okay, for example here, the register that we use for the effective address is this one. This is your data register 4. So you have to use 4 here. One, 0, 0. So that's 4, right? Then the op mode. Op mode field is based on the size operation that you use. Now for the example here is a dot byte. Byte means the op mode will be used as byte operation. So look at the operation, there are two lines over here. So which one that you need to use, you have to refer to this one. So this is going to be the first one because you're going to save the data back to the data register. You cannot use this one, right? So this is different. So you're using the first one. This is the first line. The operation is dot byte. Dot byte means 0, 0, 0. The op mode would be 0, 0, 0. Then you finish these 2. Okay. Then effective address. You are looking at the effective address over here, right? So read this one. The effective address field, okay, if it is a source operand, if your effective address is your source operand, then you are going to use this table. If, for example, your effective address is your destination, for example like this, if you flip this 1 to at the byte to G4 to possibly at this one 4000. So this is at DN to effective address. So this is actually your source will be your data register. Your effective address now is your destination. So we are going to looking at that later. So try this one first. So now is the location for the effective address is basically the source, right? The source operand. Source is over here. This is a location specified as a source operand. So this is a location specified as a destination operand, which is not. So you are going to refer to this table. So what you need to put is the mode and registers. So based on this pattern, hash $12. So you cannot use all of this, and also you cannot use the absolute short and absolute long. But this example, you are going to use hash data, which is this one, hash data, right? So you have the mode 111 and the register is 100. Mode as 1111, and your register will be 100. So you have all these informations already. So what you need to do, you have to insert all these things. The register is 4, so the register is let's try it. register is for 100, and your op mode will be 000. Your effective address register will be for mode first, right? So mode will be 111, and your register will be 100. Okay, so let's fill out that one first. The final answer is a 1 1 0 1 1 0 0 0 0 0 1 1 1 1 and 0 0. So it should be 16. Yeah, it's 16. So take all this one and convert it to hexa numbers. So 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, let's convert it. This is 8 plus 4 12 13. 13 is D. This is 8, this is 3, and this is 12. 12 is C. So the answer will be D83C. Hopefully it's correct. Compile this one. It's different, right? I think there's something wrong over here because this is 06. By right, it should be D. So it's okay. I think something a bit different over here. But we're going to have another example. Okay, let's try another example here. This is the HTC. Try add.w A1 to D3. A1 bracket to D3. Okay, so again you have to refer back to the add instruction here. So one. So the pattern will be like this. You are going to take this pattern, add effective address to DN. So this is the one. So now you're going to put the register here. Register says what? Specifies any of the 8 data registers. So data register number 3. 3 means 011. And then your op mode field based on this pattern. Based on this pattern, you are looking at this pattern. So the size is W is 001. Op mode 001. And the effective address here is this component. So it's a source, so you have to refer to the source here. Right, so this is the source operand. So this is bracket A1, so you have to refer to bracket A1. Okay, the mode will be 010, and your register number is your register over here 1, so the number will be 001. So now we fill out those things. Before that, I compile first, just to want to check whether so this one it should be done. Okay, so we going to insert the numbers. The register is 001 0 0 0 1, right? The op mode is the register is 011. The op mode is 001. The effective address is 010, and the register will be 001. Okay, let's put all the numbers together. 1 1 0 1 0 1 1 0 0 1 0 1 0 0 0 0 1. So it should be 16 numbers. 2 4 6 8 10. So it's 16. So convert it to hexa numbers as usual. Divide by 4 sections, divide by section, divide by 4 sections. So this is 8 plus 4 plus 1 is 13. 13 is D. This is 4 plus 2 is 8. This is 4 plus 1 is 5. This is 1. So the result is D851. D8 or D6? Sorry, this is D6. Sorry. This is D651. So compile it. Let's look at the answers. Yeah, it's D651 is correct. Okay. So just on the first the previous example is quite interesting that we don't get the D at the beginning. It should be D because this is a permanent numbers. You cannot change these numbers. Just now we got 0, but I don't think so it's correct. It must be D because all the while this is a permanent numbers. This is already D. You cannot change it. So let's try another example for add dot long. Okay, so let's try this one from D7 to $6500. So now the pattern will be add DN to the effective address, right? So now you have to put these values, all these values back before you can insert it over there. So let's try. Okay. Now add dot long D7 to 6500. Add dot long. So the register will base on this register D7. Okay, D7. 7 means 1 1 1. Alright. The op mode. Based on this one, the op mode is add dot long. So which pattern that you're going to use? You're going to use this pattern because this is basically this pattern. You're going to add this number to this number, and finally you're going to save this number to the effective address, which is this pattern. So this is a pattern for the numbers dn plus effective address, and going to save to the effective address too. Alright, so you have this one. So you're going to choose what? At dot long. Long here is 110. Okay, it will be the op mode will be 110 110. So next one. So your effective address now is over here. This is destination, this is source, so you have to refer to the destinations operand. Destination is over here, not source. This is source just now. So based on this table, which one that you need to pick? Again, look at the pattern here. You are going to consider the absolute short. So this is absolute short because it's only 4 digits on this address. So the absolute short will be mode 111 111, and the register will be 000. Okay, so this is the one, right? So let's look whether it's correct now first. It should be D. Yeah, it should be D. Okay, let's try to figure out on these values. So 1101 register is 111. Register is 111, right? Op mode will be 110. Effective address mode will be 111, and the register will be 000. So the final answer is 1 1 1 1 0 1 1 1 1 1 0 1 1 1 0 0 0. So this is 16. Again, like this one. So this is 8 plus 4, 1 is D. This is F. This is 8 plus 2 plus 1 is 11, is B, and this is 8. So the answer is DFB8. Is it correct? Sorry, this is close, so I have to put this one. So the answer is DFB8 is correct. So this is correct. Okay. Let's try another example, last one for the subtraction. Let's try subtraction over here. Sub dot W let's try 20,000 to D7, D6. Okay, again, you have to go to the sub function over here. Find the sub function. This is M. Okay, that's the sub one. Okay, start at 4-174. So you see that this is the patterns again. So you have to refer to each of them. Pattern is destination source, destination minus source, and the final result will be saved to destination. So based on the syntax here, you are going to refer to sub effective address to DN. So this is a pattern. This is not DN. DN is your destinations over here. So you're going to use this pattern. Alright, again it's the same method. So you already have all this one, instruction format 1001. Register is the register number here. Okay, register 6 is going to be 110, right? Op mode is based on the pattern just now. So you're going to destination minus source and save to destination. So destination minus source, which is the effective address, and save to destination. So you're going to pick out this one, this line, and the word is size over here. So the op mode is 001. Right. Next one is effective address. So your effective address now is a source, right? Source. So source, you have to put back. Look at the instruction field. So this the effective address is the location. This is for the source operand. This table is for the source, and if the effective address is a destination, so if your effective address is destination, they are referred to this. So for this example, this one is actually at the source, so you have to refer to the source table. Right? So your mode will be based on this number. So what is this? So this is how many digits. You cannot use all this, so you are going to use maybe these two. So you have to calculate the digits 1, 2, 3, 4, 5. So this is 5 digits, so it's absolute long. This is absolute long. Absolute long is this one. Okay, the mode will be 111. Mode will be 111. And the register will be what just now is 001. Okay, so you have all the informations already. Okay, then you are going to insert it. So take this one. Okay, insert all these things together. Register is one one zero. The O mode is 000, right? This one just now. This is a W 001. This is 001. Correct, right? So this is the one. Yeah. So the O mode, it will be 001. The effective address is, the mode will be 111, and the register is 001. Alright, so you have the final answers here. 1 0 0 1 1 1 0 0 0 1 1 1 1 0 0 1. So this is a full 16 bits. So convert it to hexa. Four. Okay, so this one going to be 8 plus 1 is 9. This is 12. See, this is 7, and this is 9. So the answer is 9C79. Yeah, correct, it's 9C79. Okay, so this is the example. Okay, the last one before we call it a day. So I'm going to switch this one from here, these 6 to the locations. So now the pattern will be different. Okay, the pattern will be different now. Instead of this one, so you have this one at the back, effective address at the back, and you have data register at the front. So you have the 6 number correct, right? So the op mode is based on which one? The op mode here, you are still using the word size, but the pattern is different right now. The pattern will be effective address minus D6 and will be saved to 2000 back to the effective address. So you can see that this is the pattern that you have to use instead of the first one just now. So the op mode for this one is W, right? W means 101. And the final one for this one is a mode and the registers. Effective address So you have to calculate here. This is basically 2000 only. 2000 is only 4 digits, so you have to refer to the absolute short here, and you have the mode of 1111, and the register is 000. So right now you can insert all of them. This one, cut this one first. Okay, so where is it just now? This one. Okay, so the register is 6, which is going to be 110, and the op mode is 101. The mode will be 111, and the register is going to be 000. So the final answer will be 1 0 0 1 1 1 0 1 0 1 1 1 1. Sorry. Okay, 1 0 0 1 1 1 0 1 0 1 1 1 1 0 0 0. So that's the final answer. So is it correct? 16 2 4 6 8 10. So this is 16 bits already. So this is the answer. So divide the sections that we have. No, 1 2 3 4 1 2 3 4. Okay, so this is what 8 plus 1 is 9, 13. This is D, this is 7, and this is 8. 9 D 7 8. So is it correct? Yeah, it's correct. It's 9 D 7 8. So I think I already have all the important examples that we have. So I think this is the last sorry, this is the final one, and I hope that you guys can understand. So if you cannot understand, you just drop me a message, maybe we can discuss together. Okay, thank you very much, and hopefully you guys can score on the assessment.